Hi guys. First of all, I just wanted to say thank you so much to those of you that are taking the time to watch this video. I know canceling class today was kind of an inconvenience. It's much easier for me to do this live than it is to record a video, and you have to listen to my voice for, however long. So I apologize. I really appreciate your understanding, just with family emergencies coming up and having to deal and make do and move forward. So I really appreciate your effort in making that happen. So today we're starting week 27, day 1. We have been working a little bit with combining like terms and basically applying that negative section to the opposite section down on the algebra tile mat. So that is what we are going to continue to work for today as we work towards solving for x. So the first problem that we're going to go through together is problem 2-30. And so this is kind of having to do with some substitution. So we practice this a lot with our check steps. And so again, now that we're kind of getting into two variable algebra, we're using that plugging in and that substituting to find out what the other variable is. So this is just some quick practice on this. There's another problem that's just like this on your homework. So make sure that you're paying close attention, and then you will have to finish the other 3 problems on this page. So for y equals 2 plus 3x, when x equals 4, what does y equal? The first thing that we have to do is to show what's happening here. We're substituting that value of x for x equals 4. So instead, we're plugging in that 4. Okay, you have to show that substitution. You don't necessarily have to write show substitution like I did, but you need that 2 plus 3 times 4 because that's what we're evaluating for. Then if you actually do that, 3 times 4 is 12. Order of operations means multiplying first. Then add 2, we get 14. Okay, that's the simplified version of when we simplify this expression to solve for y. So we would have y equals 14 when x equals 4. Okay? So similarly, now we have a equals 4 minus 5c when c equals negative a half. What does a equal? So we're going to plug it in. We're going to substitute this value in. And don't freak out just because it's a negative fraction and you're like, oh my God, I can't do this. Yes, you can. It's the same process. So we're literally plugging it in. Instead of c, we're plugging in negative 1/2. Okay? So we're going to substitute that value in and solve for 4 minus 5 times negative 1/2. Remember, when we have a negative here times a negative, we're going to end up with a positive. So we'll actually have 4 plus 2.5. And then if we simplify 4 plus 2.5, we solve for a equals 6.5. Okay, or 6 5/10. You have 3 more to do down here. Okay, so if you need to, go ahead and pause this video and complete that. That way you don't miss anything or forget to go back and do this. Okay, so problem 236 is the next problem that we're going to do. And now we're talking about algebra tiles to build various expressions. We've been working on this. This is just kind of a continuation of what's going on here. So in this case, Gretchen used 7 algebra tiles to build this expression. We're not actually going to build this collection. Obviously, it would be much easier if we were in person and we could physically build it, but it is what it is. We're making do here. So we have this expression up here. We have 2 positive x's, remember colored in as positive, and then open, clear, transparent, whatever you want to call it, is negative. So 2 positive x's, a negative x, a positive 1. And then down here in the opposite section, we would write the opposite of positive 3. Okay, so to do that, we're literally listing everything that's in here. Remember, everything on the top is just listed as is. We used coefficients to simplify, so we don't have to say x plus negative x anymore. We use coefficients to simplify, but we do have to list every tile. So even if there's 0 pairs, we don't want to do anything with those yet. That's the original expression. Then on the bottom half, remember, we're taking the opposite of everything that's in the bottom, which is positive 3. Okay, so when we combine our like terms and we make our 0 pairs, we see we have our x's that we can combine here, and we're left over with 1x. We still have that 1 unit, and we still have those 3 because if we flip those tiles up, remember, they become the opposite. So instead of saying the opposite of positive 3, we're just going to add a negative 3. Okay, then we're going to combine our last set of zero pairs or combine like terms. 1 plus negative 3 gets me negative 2. So simplified, this expression is represented as x minus 2. Even though there's a whole bunch of things on here, when we simplify it, this value is worth x minus 2. So for down at the bottom, there's two different algebra tile mats. And what you're going to do is build different representations of x minus 2. Okay, there's many ways you can do that, applying the use of that opposite section, applying some zero pairs and whatnot. Two different representations of x minus 2. So I chose, and you can't take mine, so good try. I chose to just do a regular x and two negative units on top. That's as simple as it gets. That's the old school way we would have built it before we learned about this bottom section, this opposite section. And then if I want to only work with the opposite section, again, you can't take mine, so don't even try. In the opposite section down here, we can do the opposite of what we want. So we can have a negative x and two positive units, because then if we apply the opposite of and flip it up to the top, then we have a positive x plus a negative 2 on top, which is what we want. Okay, so pause right here if you need to go ahead and finish that section. Okay, problem 238. Build the algebraic expression shown on each expression map below. Build the model and then simplify the expression by removing as many tiles as you can without changing the value of the expression, aka you have to follow the legal moves. Okay, so remember, legal moves. We have zero pairs, okay, or combining like terms if you're talking algebraically. Then we also have to remove balanced sets, which means that we can take away the same thing on both sides. However, we're not comparing these sides yet. Right now, we're just simplifying on the one side. So what I'm going to do is I'm actually going to cover up the one that's on the right, just so that when you know that I'm talking about this, since I can't really point to it as I'm, teaching, making a little lesson video, whatever, I don't want you to get confused. So I'm going to cover that up so that you can't see it and you know that I'm working over on this left side. So in order to list exactly what's over here on this left side, on this left expression mat, I'm going to list everything that's on top here. So I have x plus negative 2x plus 2. Then I'm going to take the opposite of everything that's in the bottom. Okay? So the opposite of negative 2. That's where I started with. Okay? Then to simplify, I can either look algebraically or look at my algebra tiles and know that I'm matching up that x and that negative x to make a zero pair. Remember, to show that, we're just going to do a line to put them together. Okay, so those are gone. Okay, so when we combined algebraically, what happened when we took that x and one of the negative x's, we're only left with a negative x on top. We still have those two units that we didn't touch right here. And then we have the opposite of negative 2 down at the bottom. Okay, so another way that we can simplify and we can get rid of what's going on to simplify and combine our like terms like we normally would do is to do what's called flip. This just means we are distributing this negative to everything in the bottom. So we're taking the opposite of everything in the bottom. To show that, we're going to get an arrow to show that we're flipping them to the top. Okay, we're flipping both of these that are in that negative section or that opposite section. We're flipping them to the top, which means that they become positive units. Okay, we took the opposite of them. That means they're actually gone. So we also have to cross those out. Make sure you are doing this on your notebook as well. Okay, we also have to cross those out. They are gone from the bottom because we physically flipped them and moved them on top. We applied that opposite of everything down here, that distributive property of the negative. So now we still have our negative x on the top, didn't touch it. Still have 2 on the top, didn't touch it. But now we have 2 more on the top. If you remember when we talked about adding and subtracting integers, add the opposite. So if we had 2 minus negative 2, what we would have done is done 2 plus positive 2, or 2 plus 2. Conveniently, that's what we have up here is 4. So our simplified version, after we've done all of our flipping and our zero pairs, we can't remove balanced sets if we're only talking about one algebra tile mat, is negative x plus 4. Done. Okay, that's my final simplified answer over here. If you still need to catch up, make sure you pause me right here, because we're going to keep on going. So looking over at the right, we're going to start very similarly by writing our expressions in what's exactly represented here. So we're just going to list everything on the top, x plus a negative x plus 1 plus a negative 2. This is all on the top. And then I'm going to take the opposite of everything on the bottom. So the opposite of x plus a negative 3. And of course, I'm picky and I don't like when it goes out down to one line, so I'm going to make it shorter. You don't have to have those parentheses. I know I did some extra parentheses for separation, just so you know how each of those numbers, those terms, match up to each of those algebra tiles. Because I know this is also a review for some of you with algebra tiles, because I know you're not a fan. But it does make algebra more tactile and more a physical representation as opposed to theoretical. So that is kind of nice about them. So parents, if you're watching this, this is why. Okay, so we're going to start very similarly. We're going to make our 0 pairs. So I have an x and a negative x. I'm going to take those and combine like terms. So I have a 1 and a negative 1, made more 0 pairs. So all I'm left with on top is that negative 1. So if I have, remember I had that x and my negative x, okay, and then I had 1 and negative 2. When I took those and combined my like terms here, if I were just working algebraically, I would only be left with negative 1 on top. I didn't do anything to the bottom, so I still have the opposite of x plus negative 3. Okay, so I have negative 1 on top, then I have the opposite of x plus negative 3 on the bottom. Okay. So to simplify, I'm going to flip all of these from the bottom, aka I'm going to distribute that negative and take the opposite of them. Okay, so I'm going to take the opposite of my x, which is going to become a negative x. And so this x is gone. We flipped it up to the top, which means it's no longer on the bottom. We got to cross that out as well. Then I have my 3 negative units that I have to flip as well. So I'm going to show my arrow to show them going up to the top. Oh, see, I tried to get fancy and copy and paste, and that's what happens. This is why Miss Miller doesn't do all that. Extra. Ha, worked that time. Okay, so I'm flipping these 3 negatives up to the top, which means they become positives. Okay, and it means that when they're down at the bottom, they're gone. We moved them, physically flipped them to the top. So they are no longer existing in the bottom. No longer existing. Bye-bye. So on the top, currently, we have a negative x, a negative unit, and 3 positives. This is as if we distributed that negative to everything in the parentheses. So we still had our negative 1. That was left alone. This little guy was left alone. Then we distributed our negative. So we have a negative x and a positive 3. Okay, because we took the opposite of everything in that distributive property. That's the process of flipping. So we're left with negative 1 minus x plus 3. And hopefully you see right away that there is another 0 pair that we've created to eliminate that negative 1 and one of the positive ones. So we're left with a negative x plus 2. So because if we combined our 3 and our negative 1, if we did negative 1 plus 3, we would have positive 2. So our final answer here is negative x plus 2. Again, if you need some more time to make sure all of your arrows and your lines are drawn on here, be my guest. Make sure to pause it so that you can continue. But we are going to continue to problem 248. So with problem 248, comparing expressions. So now we're going to apply that third value or that third legal move of removing those balance sets or adding balance sets, okay, like we've talked about, because now we're comparing sides. We're not going to do as much of the simplifying to get the x together and whatnot, flipping the sides or anything like that. We're not doing all that yet. We're just comparing which mat is greater. How do you know? Okay. So if you look, the old school way of showing -3 is just to put those 3 negative integers on top. Done. Boom. But now that we have this bottom section, we can also represent negatives on the bottom by doing the opposite of whatever it is. So over on the right side here, we have the opposite of +2, which is -2. But we can also represent this as -2. So if you were trying to compare which is greater, -3 on top or the opposite of +2, hopefully you would have said that the right is greater, because when we simplify this and flip these up to the top, -2 is greater than -3. And you can see that right over here in the explanation, that -2 is greater than -3. Think about it on a number line. -2 is further to the right, and I don't know if this is mirrored or not, so I guess I shouldn't be doing left and right with my hands because that's just going to mess you up, but story of my life. So our next job is to simplify using these legal moves that we've been talking about. So we have this big jumble of piles over here, and we're trying to figure out which is greater, left or right. So the very first thing we need to do is list the expressions and show exactly what's going on here. So over on this left side, we have an x plus 2 plus a -2, and then the opposite of +3 here. Similarly, over on the right, we have a positive x on top, 2 positive units, 3 negative units on top, and then the opposite of 2 negative units on the bottom. Okay, so if we were to write a as if it were an algebraic expression, we would represent it as x plus 2 plus -2 and the opposite of +3. Okay? Then on the right side, if we were to represent this as an algebraic expression, we would have x plus 2 plus -3, and then the opposite of -2 down at the bottom. Obviously, this needs a lot of zero pairs going on, so we have some zero pairs over here, we have some zero pairs over here, and then we obviously have to do some flipping as well. Okay? So on the left side, when we simplify that, we create our zero pairs, we take the opposite of those 3 positives, we get x minus 3, or x, and then the opposite of 3, to simplify on the top with x minus 3 as our final value for the left side. Okay, after those zero pairs and after flipping. On the right side, once we simplify, we take our zero pairs, we flip, we make more zero pairs, etc. We get x plus a -1 after we do our zero pairs, and then the opposite of -2, which is ending up as x plus 1. Okay? So the left is worth x minus 3, and the right is worth x plus 1. If we remove those x's from both sides, and this is what you're going to put on B, so you're going to need to pause me here so you can explain it in your words, the left side is worth -3, and the right side is worth +1. So the right side is actually greater because it has a greater value. Okay, that's what you're putting in part B. I'm not going to write that for you. So those of you that think you can just pause and just, go ahead and copy what I have, you actually had to listen to me there. You're welcome. Okay, problem 249. Our good friend Carl simplified some algebraic expressions. He recorded his work on the diagrams. So we are just identifying what's going on here. How did we know what he did and why? If we look at A, we see a bunch of tiles, and then over here we have a positive and 2 negatives left. These circles are showing our zero pairs. We would normally just draw a line through them and have our leftovers, okay? But they decided to show those with zero pairs. So he used zero pairs to simplify, with the left being worth a total of 1 and the right being worth a total of -2. Which makes the left side greater than the right side. Make sure you pause if you need more time to write this down. Then we continue with over on the left side, we see these down at the bottom flipped up to the top and then simplified. But be careful here, because even after we do that flipping, we still have zero pairs to cancel. So the left is actually worth 1 and the right is worth -1. So which is greater? That's your job to fill it in. He flipped the tiles from the opposite section and then did zero pairs to simplify. Okay? Part C. Now we're removing an x from both sides. Okay, with that legal move, he's removing balanced sets. You need to figure out what's the value of the left side and what's the value of the right side. When you have those values, you'll be able to tell, is the left side or the right side greater? That's what you need to fill in, okay? Then finally, we have our last page, which is just the legal moves. These are examples of everything that we've been talking about. We have zero pairs, which is also considered to be combining like terms. That looks like when we make these zeros or they're worth nothing, positive one and a negative one together is making zero, and that's helping us to combine like terms. Then if we remove and add balanced sets, okay, we're doing the same thing to both sides to keep it balanced. We're keeping it balanced by adding or taking away the same amount on both sides to keep things balanced. Then our newest version of our legal moves is what we call flip. Okay, all that means is we're distributing the negative to everything in the bottom section, in that opposite section of the tile mat. Everything becomes the opposite. So if we're taking the opposite of a negative, it becomes positive. If we're taking the opposite of a positive, it becomes negative. Finally, your homework for today, there's 3 problems. They're exactly like what we did in class. I even copied and pasted them on here for you. That way you can just do them directly as opposed to having to go through and find it on the website. I know that can be difficult. Actually, it should say day 1, not day 2, and that's going to bug me, so I'm going to fix it. So you are writing and simplifying these algebraic expressions. You don't have to build them if you don't want to. If you don't want to draw those on your paper, that's fine. Then for 252, you are combining like terms, aka just simplifying. Remember, x squareds are different than x's. XYs are different than x's and y's. Think about their tiles. If you want to draw, go for it. You don't have to. Then just like our warm-up on 230, this is some substitution practice where we're substituting in one variable to solve for the other variable. Make sure you follow order of operations. Have a fabulous time completing all of this. I hope this video was helpful. If it wasn't and you need more help, I have office hours on Wednesday from 10:30 to 11, also on Friday from 9 to 10, and then I have extra math help from 2:30 to 3:30 on Thursdays. So I really appreciate your help today. I hope you have a wonderful day. See you later.